red and green overlap, you get yellow. Where blue and green overlap, you get cyan. My cyan is not great. That doesn't look like cyan. That's a little closer. Okay. And where the blue and the red overlap, you get magenta. All right, number 9, describe complementary colors. I meant to write describe secondary colors. And it's what you get when mixing colors of light. So when you mix colors of light, what you get are the secondary colors. Okay, so what are the subtractive primaries? So what we've done so far are additive primaries, right? When you add all the colors, you get white. What we're going to talk about now is the subtractive primaries, which means if you take all the colors out, what do you get? You get black. So these are the subtractive primaries. Come on, pen. Really? That's how we're going to be? Okay. So, what are the subtractive primaries? Now, this is what your art teachers have talked about. Your art teachers have always talked about subtractive primaries. So, one of them is yellow. Okay? One of them is, besides yellow, what's another one? Good try. Not red. But we have talked about it. Nope, not orange. We've talked about it. Good. Yep. Well, nope. Close. Magenta. Yep. And cyan. Now you may be saying to yourself, Mr. B, there's no way those are the primary colors. Hey, have you ever looked at ink on your color printer? What are the 3 colors of the ink in your color printer? Yellow, magenta, and cyan. They're not red, blue, and yellow. They're magenta, yellow, and cyan. So again, your art teachers have lied to you your whole life. Okay? They didn't even think twice about it. They just straight up just totally lied to you, bold-faced. To be fair, I'm guessing they didn't know. And I will take this to the absolute mattresses if they want to fight with me about what the primary colors are. I will absolutely go down and dirty on it. Okay, so yellow reflects what? We've already talked about this. Yellow reflects green and red. God bless you. Okay, we've talked about magenta. Magenta reflects blue and red. And we've talked about cyan. Cyan reflects blue and green. Okay, I'm about to blow your mind. Okay? Prepare yourself. Here it comes. That means that if red and green are reflected, yellow absorbs blue. If blue and red are reflected, magenta absorbs green. And if blue and green are reflected for cyan, that means it absorbs red. Oh my gosh, the primary colors are still red, blue, and green. They're still red, blue, and green. These are color subtractive, which means they take the colors out. So the primary color for yellow, I would argue, is blue, because that's the color it takes out. The primary color for magenta is green, because that's what it takes out. Primary color for cyan is red, because that's what it takes out. So that's what I would argue the primary colors still are, red, blue, and green. It's just they're taken out instead of added in. That's the difference. That's the difference. So these are color subtractive primaries, yellow, magenta, and cyan. And what they do is they take out the light primaries, blue, green, and red. If you mix all of them together, you get black. Which again is how your color ink printers work. All right. How does your eye work? So we're going to take a little bit of a detour. We're going to talk about your eyeball. So here's your eye. Here's the lens. Okay? And let's say you're looking at a red arrow, for lack of me wanting to draw anything else. Okay? Light comes into your eye. Light is your eye is a lens, so it bends the light. It focuses at some point further on. That point happens to be the back of your eye. And it creates a real image. So, two things to notice about the real image. So, well, first of all, it is a real image. Okay? Second of all, it's upside down. Well, we've talked about this. All real images are upside down, so that's not surprising. But here's what is surprising. Things don't look upside down, right? I look around and I can see you all sitting right side up in your seat, so it doesn't look upside down. Except it is upside down. So what happens? Your brain flips it. Your brain knows it's upside down, and your brain is like, that's dumb, and flips it right side up. So you are seeing the whole world upside down, but your brain right sides it up so you can actually see things normal. So it means when you're born, you see things upside down, but because you don't know what's going on. And as you get older and as you develop, you flip it right side up so that you can actually see the world the way things make sense. It's mind-blowingly crazy, but that's what happens. Okay? All right. Your eye is made up of two different things. It's made up of things that are called rods and things that are called cones. In the back middle of your eye, you have the cones. And on the edges of your eye, you have the rods. Now, they're not particularly imaginative. Rods are basically straight cells, and cones are basically conical cells. So they're not very creative. But here's what they do. Rods see brightness, and cones see color. So when you look ahead of you and you see something is blue, you see something is green, you see something is yellow, it's the cones in the back of your eye that are figuring that out. The cones in the back of your eye are figuring that out. Okay? So the brightness is the rods. So when I look out and I see that underneath the light it's a little brighter, or in this corner it's a little darker, that's the rods working. So the rods tell whether it's bright or dark, and the cones tell whether it's some color or another. Here's a couple of interesting things. Since the cones are in the middle of your eye, the best way to tell if something is a color is to look straight at it. If you look off to the side in your peripheral vision, it's harder to tell what color it is. Okay, so I can't really tell very well what color Caroline's wearing, but I can tell very well what color those of y'all in the middle are wearing. Okay? It's harder to tell further out because that's my cones, or that's my rods, not my cones. Another interesting thing is since cones see color, not brightness, cones don't work very well at night. So if something happened and the police are talking to you and they're like, what color car did they see? or what color did they get away in, and you're like, oh, it was a red car for sure, I absolutely know that. You just don't, because it's at night, so your cones don't work as well. So it might have been red, but it might have been like a dark green, or it might have been a lighter blue, or it could have been something else that just, in the darkness, your eyes play tricks on you, and you think you know what you saw, but you don't actually know what you saw. So that's just something, if you've ever seen me on a day where I don't match, which is almost never, but occasionally it happens, it's because I get dressed in the dark in my closet and I can't tell what color my tie is. So I usually have my ties in very specific places, so I know which tie is in which spot, so I know which tie to grab with what shirt color. Usually all on point, but occasionally it doesn't work out for me. And that's why, because rods just see brightness. Colorblind, so if you're a person who's colorblind or you know someone who's colorblind, means your cones have trouble distinguishing between colors. And those colors are usually red and green. Not always red and green, but usually red and green. It can be violet blue, that's another common one. Also, colorblindness is almost always guys. It's almost always men. It's like 75% men, 25% women. So, Seth, are you a lucky winner?
No. I don't think I'm colorblind, but everyone else does.
So everyone thinks you're colorblind except for yourself?
Yes.
She needs help picking out colors because she doesn't know what's actually about to come.
You should take a colorblind test.
I did.
Oh. Did you pass?
I don't know.
You took a colorblind test and you failed, but it's just wrong, probably.
Probably.
Yeah, I bet you're right.
It said, like, what number is it? There wasn't a number there.
Oh, yeah, that's no problem.
Okay.
Actually, that's kind of weird, because if you're colorblind, you see one color, but if you're not colorblind, you see or one number. If you're not colorblind, you see a different number, and you saw no number.
No.
That's a problem. Yeah, that's not great, Caroline.
It's just you, Cal.
It's just, that's right. You're not colorblind, you're just Caroline.
Yeah. I just had trouble differentiating. It's not that I'm colorblind.
That is literally what colorblind means.
Really?
Yeah, colorblind. It's not that you can't see them. It's that you have trouble differentiating between the two colors.
Oh, maybe I am colorblind.
I had a student one time, I've only met one person like this at all, whose cones didn't work at all and saw everything as rods, which was he saw everything as black and white. So he did not know what color looked like, which is a super, super rare thing. Yeah, dogs I don't think have cones. So dogs see colorblind. Also, different animals see different colors than us. So we see these colors. This is the visible light spectrum. Bees see ultraviolet also. So bees can see ultraviolet. That's why if you wear like bright colored shirts, bees chase you. And that's because bees can see the ultraviolet reflecting off those shirts and they're like, sweet, a giant flower. And then they chase you. And that happens to my daughter all the time, and she flips out constantly. So there you go. Any questions on color or any of those things?